It's the hard-packed launching pad for snowboarders, the slick racing track of cross-country athletes, and the speedy slope for downhill skiers.
The snow conditions are huge. You know, some races you'll have really icing conditions, some races are soft.
Snow is an essential part of the 2014 Olympic Winter Games. In fact, organizers in Sochi are worried whether or not they'll have enough of it. The science of snow, how it's formed and how it reacts, has been studied by scientists for centuries and continues to this day.
Snow is the crystallized form, the solid form of water, but that is formed in the atmosphere so that it is able to take on a unique crystal structure.
Sarah Conrad is a glaciologist at the University of Wyoming, but unlike many of her colleagues, she's also a former Winter Olympian.
I competed in the 2006 Olympics in Torino, Italy, and I competed in biathlon and in cross-country skiing.
Snow is a form of precipitation that begins as tiny liquid water droplets in the clouds. In order to turn into snowflakes, these water droplets need to be what scientists refer to as supercooled.
You're right on that point of going from liquid to solid. We have a freezing temperature for water, but that freezing temperature can change based on your altitude.
Supercooled water remains in liquid form, even though it's below freezing temperature. For it to freeze, it needs to come in contact with other particles like dust. These particles provide the impetus to start the freezing process.
To make that transition, which takes energy to go from water to ice, it needs something to start it. It needs a nucleating particle. So a piece of dust, a piece of random gases, a lot of emissions from smokestack, different things like that. When the water hits that particle, it can begin to freeze and form a crystal structure.
Conrad demonstrates this process using a bottle of supercooled water, pure distilled liquid water that is below freezing temperature.
It's pure distilled water, so it doesn't have any particles in it.
Disturb it with a few good smacks and instant ice crystals.
See the ice slush up at the top?
The ice crystals that form in the clouds become snowflakes.
As they accrete and freeze, they'll grow outwards in that pattern.
Snowflakes come in many different shapes and sizes, but can be grouped into two categories, plates and columns.
The kind of stereotypical snowflake that we're used to, those beautiful six-fold symmetric crystals, those are called dendrites, and that's a type of plate.
Court Anastasio is a chemistry professor at the University of California, Davis, and funded by the National Science Foundation. He says that the size and shape of snowflakes is determined by two important variables, humidity and temperature.
Dendrites form under conditions where you have a lot of water vapor. If you have less water vapor, you get much simpler shapes. It's small plates, small columns.
Once the snowflakes land on the ground, physical changes begin to occur almost immediately.
It gets blown around by wind, can be broken up into smaller pieces. The snow crystal shape changes.
The crystals start becoming rounder and smaller. And once they're round, they're more like ball bearings. And at that point, then you can ski across them much more quickly.
Sometimes there are those courses or those snow conditions where you're just like,
In Sochi, after 2 mild winters, organizers have made contingency plans that include storing about 588,000 cubic yards of snow under insulating blankets in nearby mountains. But experts worry that stored snow can't quite compete with freshly fallen powder.
It's going to melt, and then when it gets cold again, it's going to refreeze. And so it's going to be really icy.
Though tiny, soft, and delicate, when snowflakes accumulate to form blankets of several feet, snow becomes the ultimate playing surface upon which Olympic dreams are made.